Now we are going to discuss how to evaluate the double integral in a polar coordinates. The area of the region bounded by two polar curves r equals to f1 of theta and r equals to f2 of theta along with two lines theta equals to alpha and theta is equals to beta can be computed from the following formula. To compute this area, identify the functions f1 of theta and f2 of theta that describe two polar curves. We have to determine the limits of integration alpha and beta. Set up this integral and evaluate the integral to find the area. Now we can see a mathematical problem related to evaluation of double integral in polar coordinates. Evaluate the double integral over the region R, where the region R is the area included between two circles r equals to 2 sin theta and r equals to 4 sin theta. To evaluate the integral, basically we understand the region. Here the curves r equals to 2 sin theta and r equals to 4 sin theta represent circles in polar coordinates. One can observe that the circle r is equal to 2 sin theta has a radius of 1 unit centered at 0, 1 in Cartesian coordinates. The circle r is equals to 4 sin theta has a radius of 2 units and centered at 0, 2. The region R is the area included between these two circles. The curves intersect when 2 sin theta is equals to 4 sin theta, which implies that sin theta is equal to 0. This occurs at theta is equal to 0 and theta is equal to pi. We have to set up the integral for the region R. The limits for R will be from the inner circle to the outer circle. Here R goes from 2 sin theta to 4 sin theta, theta goes from 0 to pi. Therefore, the double integral can be expressed as integral 0 to pi integral 2 sin theta to 4 sin theta r power 3 drd theta. Let us evaluate the inner integral. First we evaluate the inner integral. The inner integral of r power 3 is r power 4 by 4. Now evaluating from 2 sin theta to 4 sin theta, we have 4 sin theta power 4 by 4 minus 2 sin theta power 4 by 4, 1 by 4 times 256 sin power 4 theta minus 16 sin power 4 theta is 1 by 4 times 240 sin power 4 theta is 60 sin power 4 theta. To evaluate the outer integral, now we have integral 0 to pi 60 sin power 4 theta d theta. To evaluate this integral, we can use the reduction formula for sin power n theta. Calculating these integrals from these formulae, after simple calculation, we will get the area as 45 times pi by 2.